Hi everyone, welcome back. In the previous video we learned about k-nearest class, and today we are gonna learn about DTrees. Actually this is a comprehensive class, so I'm planning to divide into two videos this series. So the first one we are gonna talk about what DTrees is and how to initialize its class and how it looks like with our simple example. And also in the next video we are gonna focus to these parameters and how they are affecting the result. Okay. I already prepared this simple presentation which has 5 cases. Actually this D3 stands for decision tree, so you can understand from the name how it's working. For example, after training is done, it's creating a tree which is a decision tree we are calling. So once the new data is coming according to the internal nodes, for example internal nodes are the stop station for going to the result, for going to the end node, which is we are calling as leaf node in here. So from the beginning the new data is yes no, by yes no questions, which is also written in here. According to this question is visiting the internal nodes and is going to the end node, and this end node is gonna be our class ID, which is gonna decide after training, after decision tree is done. So basically it's working in this way. Also also I'm planning for KNN. So since we already learned KNN, also we trained it with Minis dataset, which is handwritten dataset recognition in the previous videos. You can also check them. For this one also I'm planning to make a separate video which is gonna be a comparison video D3 and the KNN. It's important because by that we can understand how they are acting, how they are behaving to the same data, so we can check that also in that video. So I also want to separate that from this video. And also the people who are really interested with the algorithm behind how it's working, they can check this Gini impurity algorithm, which is a decision tree algorithm. So in the behind of D3 this is working, this algorithm is working. So basically D3 is like this. So we can switch to the code part, and this code is from the previous video and is for KNN, and let's see how it was working before previously. So simply we have 3 sample data, blue, yellow and the red, and new data we are putting is just trying to know which group it belongs to. So this was for KNN, and now I want to just use the same code since we coded this from scratch in the previous video. I don't want to go by one by, so you can check, if you directly watching this video you can check the previous KNN videos. So the usage is gonna be the same like the KNN, so all we need to do is just calling the D trees classes in here, and the name also I want to change as D3, and okay, decision trees, and the initialization of the object is done. Similarly we need to call D3 train here, and also what it says, find nearest. Okay, so it has different name, I think. Let's see. Okay, predict. So we need to give samples. Results is just gonna return to me. I think it's gonna return, where is result? Predict. Okay, predict is in the base class. Predict. Okay, it's in here and it is returning float type, which is gonna be my class, so it's okay. And sample I'm giving, sample is this one, so for this one we do not use result, and this result class I'm gonna write. So okay, I can give the same sample which is for KNN, it was giving 0 class ID correctly. Let's see for this one also, but I think I need to also assign something, but let's see. Okay, it crashes, so because so since we are dealing with a small amount of data, which is actually 5 for each class, so it's we can talk about this in the next video, but just for now I need to assign some depth which is needed. I think 10 is suggested, and the other one is gonna be the something like false, set CV false. Okay, this can be 0 for now. So this tree is important if you are dealing with small amount of data, since we are dealing with that for now. we can talk about them in the next video anyway. So with this data, it's giving me 0, which is belonging to yellow. But let's see, now I want to make around, for example, 155. Let's see how it looks like. Yeah, you see now, it says this belongs to blue, but it's actually, you can easily say yellow, but it's not clear. You are telling this belongs to yellow because of the distance. KNN totally working. By the way, the title is still KNN, but this is D3 anyway. We can change it. Okay, anyway, so you can say this is belongs to yellow, so this is wrong, but it's not wrong because D3 boundaries and the KNN boundaries is depending to different things. KNN is working with distance, but D3 is working with a different boundary classification than the KNN, so we cannot directly judge this is wrong. So in the next video, for comparison, I'm mostly want to talk about these things, but anyway, for now we can skip. So let's put a point around, oops, maybe here. So let's say maybe 355. So it's now here, it says 1 is correct, but if I put something here, maybe which is okay, let's see, 444 to 444, and it's saying still this belongs to red, which is this one. Oh, previously also it's saying red, which is in here. Oh, it still says this belongs to red. So let's put a this one, 255. Now it still says this belongs to red. Maybe it's also possible, maybe it's just eliminating because it's possible it's eliminating the yellow, because also we need to put a different parameter, which is gonna be minimum sample count, maybe 2. Now you see it's giving yellow. So yeah, these parameters I want to focus to in the next video. That's why previously it was not considering the yellow. So we can give still that very beginning number, which is oops, this one. Okay, just put that again, set minimum sample count as 2. Let's see, it's gonna still give blue. Now it's giving blue, but actually it's close to yellow. Now expectation, I mean the result didn't change. The first example we tried is still saying this belongs to yellow, blue. Okay, so for this video simply I just want to talk about the initialization of this D3. For small amount of data you need to set these two things actually is needed, and this one is for, yeah, we can also check in the next video again this one. And yeah, the data preparation is same, only the end function, which is previously KNN was using find nearest, find predicted, and this one only using predict function. For this video I'm done. Actually my target is done for this video, and in the next video we will talk about the parameters. See you in the next videos.